Hello everyone and welcome to the Golfing and Other Languages series. In this video series, I'll be going over explanations and explaining my thought process and solution for problems using Golfing languages other than Jelly, which I have a different video series focusing on Jelly. So the problem we'll be looking at today is find the Erdős wood's origin. Credit to caird coinheringaahing for this problem. So the problem goes like this. Consider some positive integer k which will be given, and for some a we have the sequence a plus 1, a plus 2 up to a plus k, so the inclusive range between a and a plus k. Is there a pair of a and k such that for every a plus I in the sequence from a to a plus k, either the GCD of a and a plus I is greater than 1, or the GCD of a plus I and a plus k is greater than 1? So recall that the GCD of two numbers is greater than 1 if and only if they're not coprime. And so what this is basically asking is there a and k such that in the inclusive range a to a plus k, no number is coprime to both a and to a plus k? It turns out that yes, there are such a-k pairs, and in fact there are infinitely many such pairs. For example, if you choose k equals 16 and a equals 2184, for each one you can calculate the GCD with a and a plus k to get a bunch of pairs of GCDs, none of which are 1, 1. And so to verify this, let's try it out. We take 2184 and we take 16. Now actually we want 2200 because that's the sum of a and k. So that's our list itself. If we duplicate this and if we get the range from 2184 up to 2200, we get these, and then if we take the Cartesian product and take the GCD of each list, I should swap these two elements before taking the Cartesian product. And we take the GCD and then we wrap the list into pairs. You see that for each pair, at least one of the two numbers is greater than 1. In other words, no number in the range from 2184 up to 2200 is coprime to both 2184 and to 2200. So the problem here is given some k, output any positive integer a that satisfies this pair. And you can assume that k is an Erdős wood's number. The output doesn't have to be the smallest such integer, but here we'll be using the find first integer built in, so it's easiest to output the shortest anyway, so the smallest anyway. So the solution I'll be exploring today isn't particularly efficient. In fact, it probably only ends up running for the k equals 16 test case. So the built-in we're looking to use is the first integer where a of x is truthy, where a is the function we'll be using. So we have this built in here, and we'll provide some lambda function here, which checks if a given value of a is valid. K will be given as an input, so within this function we'll be able to refer to the 16 or whatever the input is using the first input in input history built in. So before we do that, before using the find first integer as truthy, we need to make some function that will be truthy if and only if a is valid. So we'll just apply this function, and we'll begin by applying it to 2184. And this will just help us see the results. So if we wrap the entire stack within this function, we get 2184 because the 16 isn't provided. So we'll use the first item from input history built in, which will push the 16 onto the stack, and we get this, 2184 and 16. So now we don't actually want 16, we actually want the sum of a and k. So we'll use the cumulative sum built in. What this lets us do is since we have a list of 2 elements after wrapping the stack, we can use cumulative reduce to keep the first element A, and then the second element goes from K to A plus K. And so this gives us our familiar pair 2184 and 2200, which is exactly what we want. So now how do we go from that to the range? Well, we can try to push the values back onto the stack, but then we'd still have to manually do the A plus K part, and we'd end up wasting a lot of bytes doing so. So instead what we can actually do is go from this directly to the range. Recall that we were using the dyad inclusive range from A to B. So instead of calling this dyad on 2 elements, what we can actually do is reduce over this built-in. In other words, unwrap. So the reduce by function built-in is just R, and we'll make a 1 byte lambda. And so essentially what this means is we're going to reduce the top list over inclusive range. And since the top list only has 2 elements, it's a pair, reduce just places the inclusive range built in between them. And so if we run that, we see that we get the pair we want. It's actually backwards, but the other thing is it doesn't actually matter for this challenge. However, we've lost our original pair now, which we still need to keep around, so let's duplicate right before we reduce, and this will give us both the pair and this. So next we want a Cartesian product and GCD each. Before we take the Cartesian product, we actually need to swap the order, and that's because we need the lists to be grouped together by these elements so we can slice it into groups of 2 later on. It needs to be grouped by the elements in the sequence, not by the elements in the pair. So we swap, and then we can take the Cartesian product. So this is the Cartesian product now, and we'll notice that it's grouped by the first element, of course, and so this way it comes in pairs, which we can then group up later on. And so let's take the GCD of each list. And we see that this output format is roughly the same as this, but the structuring and ordering is a bit off. So the first 2 elements are the last pair here, because again, our output came out backwards when we reduced by range. And then the second pair is 1, 3, which we see here. The third pair is 2, 14, etc. So now let's wrap this into groups of 2. We'll push 2 and then use the wrap into chunks built in. All right, so this gives us our pairs. And now, according to the problem, we just need to check if there are any 1, 1 pairs, and if so, we need to provide a falsy value. So we could try to check for that 1, 1 pair directly, but one trick that we can do that actually was a golden tip that caird found for my jelly solution that I'm now applying here, is we can decrement each value and look for a 0, 0 pair, because that will be a lot easier. Note that GCD can only give positive values, at least in our current domain. And so if we subtract 1, we'll keep it at non-negative values. And therefore, since 0 is going to be the lowest element that can exist, if we sum each pair, we'll get 0 if and only if the pair is 0, 0. And otherwise, it will be greater than 0. If there were negative numbers, this trick wouldn't work because the pair -1, 1 could show up and mess up our results. So let's decrement each value. And we see now that we have a pair of a bunch of values, but there are no 0, 0 pairs. If we change this to 2 and 8, 3, you'll notice a lot of 0, 0 pairs show up. So how can we find this? Well, if we take the sum of each pair, then you'll notice that there are zeros here, but if we change it to 2, 1, 8, 4, there are no longer any zeros. And so now the problem goes from finding a 1 pair to finding a 0 pair to finding a 0. And at that point, to find a 0 in a list, you can just take the product of the list. Since all of our other values are non-zero, the product will be 0 if and only if there exists at least 1 0 in there. And this actually completely solves our problem because now the product is the output, which is 0 for anything except when there are no numbers that are co-prime with both a and a plus k. Now this number doesn't actually matter because as long as it's positive or non-zero, it's truthy. So let's remove our spaces. And now we can just call the first integer built in, which will look up from 1 up to whatever number. Give it a second to run. And we see we get 2,184. So this solution comes out to 20 bytes, and it's the exact one I submitted to the CodeGolf problem. If you have any goals or tips for shortening this, please leave them as a comment below or as a comment on my CodeGolf post down here. I'm relatively new to Vyxal and I don't really use stack-based languages all that much, so I'd appreciate any tips that anyone has. So thank you everyone for watching. If this video helped you understand or get interested in Vyxal more, please like the video and subscribe for similar content. If you want links to how to use Vyxal, there's the interpreter here. It's hosted on Python Anywhere by CodeGolf user Vyxal, who created this language. It's a pretty cool language. It's stack-based, so it's an easier entry point than some of the other tacit-based languages like Jelly. And you can find all the documentation on the GitHub repository under /Vyxal/Vyxal. It's just in the docs folder, and you can look at it formatted as just a raw txt or as a table as a markdown file.